Welcome to the physics class. I think you have enjoyed your summer vacation very well. And I think you remember what we have discussed last classes. I think chapter 1 is already over. And for the quarterly exam, we will be having first two chapters, chapter 1 and 2 for physics. That's the syllabus, chapter 1 and 2. Okay. Today, we are entering into the second chapter. The name of the second chapter is motion. The name of the second chapter is motion. What is motion? Movement. Movement of the body is called motion. So, before we are entering to the word motion, you have to study about rest. What is rest? Rest means it's not after getting tired and you don't think that when we are doing a lot of work or when we are playing a lot, we will be getting tired and after that we used to rest. No, we are physics students. In physics, rest is something else. In physics, rest is something else. So, what is rest? That is going to be discussed first. In physics, rest means the position with respect to a fixed point or an object in its surrounding do not change. Do you understand anything? If the position of the body with respect to its surrounding is not changing, then I can say that the body is at rest. For example, suppose you have kept that is this duster I am going to keep on my palm, okay, and I am counting the time for 1 minute if I keep also, if I am not changing the position with respect to the surrounding of this duster, I can say that this duster is at rest. This duster is at rest. Okay, so the body is said to be at rest if its position with respect to a fixed point or a fixed object in its surroundings do not change. For example, you are coming by bicycle, right? Some people are coming by bicycle and you are parking the bicycle somewhere there. And you have come to our school and from the school veranda you are just looking at your bicycle. After every 1 period, you are just checking the cycle. The position of the cycle is not changing. If the position of the cycle is not changing with respect to the surroundings, we can say that the cycle is at rest. I hope you understand. Is it not? Then what will be motion? What will be motion? Motion defines. We are just cutting this word. The body is said to be at motion. The position with respect to a fixed point or an object in its surrounding changes. In its surrounding changes, we can say that the body is under motion. For example, I kept this chalk on my palm. Okay? Then I am observing this one. Just rolling and rolling and it has reached somewhere here. Earlier I kept here, after 2-3 seconds I have seen that it is here. So the position with respect to my palm surrounding is changed. If the position of the body changes with respect to time, with respect to its surrounding, we can say that the body is under motion. And in the textbook page number 17, one picture is given. A car is parked just under a tree, and when the car is parked, it is not moving. We know that. That means we are just changing the position we are observing the position of the car with respect to that tree, that is object. Okay, the position is not changing, so we can say that the car is at rest. If the car is running, what will happen? Tree is remaining here. Car will be going far away, changing their position and going far away. So we can say that the car is under motion and the tree is at rest. So we can say that motion is relative. why motion is relative. Suppose we have to combine, that means depending upon the observer, the body can be at rest or the body can be at motion. Very simple. Okay? You people have, anyway, you might have traveled in a bus. Some people are coming by school bus also. When we are traveling in a bus, we are fixing the surrounding and the object. You two are sitting on a seat. Bus is traveling. You are looking each other, or you are sitting there without changing your position. So, with respect to you, your surrounding inside the bus, you are not moving, you are at rest. Because compared with you and your friend, your position is not changing with respect to time. So, we can say that you both are at rest. And if you are observing a person standing on a road, with respect to that person, your position, you are coming from far away, reaching to that person near, and again you are traveling. So your position with respect to that person is changing, and that according to that person, you are under motion. You are under motion. But according to you and your friend, you are at rest, even though the bus is running. So we can say that the rest and motion are relative. Then again, next one example is given. A football kicked by a player, the hands of the clock or a flying bird in the sky are in motion as long as their position keep changing. For example, if you throw a ball or a footballer is taking the ball, at that time suddenly what will happen? He is going to take the ball and keeping at a position, for example, goalkeeper. So when it is kept there, it is not moving, it is under rest. And he is kicking the ball. When he is hitting the ball, it will start moving. And after some time, what will happen? Again, it will come to rest. Is it now? Then, this is regarding rest and motion. Rest means what? If the body is said to be under rest, the position of the body with respect to its a fixed point or with respect to a fixed object, the surrounding should not be changed. If the surrounding is changing, we can say that it is under motion. Now we are going to discuss about types of motion. Mainly we are discussing 5 types of motion. First one is translatory motion, second one is rotatory motion, third one is oscillatory motion, fourth one is repetitive motion, and fifth one is random motion. Fifth one is random motion, and one more type of motion is there, that is combination of motion. That is whether this any of more than one motions are come under one time, then we are saying that it is a combination of motion. First one, translatory motion. First one is translatory motion. What is translatory motion? If an object is moving such a way that every part of the object moves through the same distance in same interval of time, then we can say that the object is at translatory motion. If an object, every part of that object is moving same distance in same interval of time, then we can say that the object is under translatory motion. For example, a car is running. Every 1 minute, if it is able to cover 1 kilometer, then we can say that it is under translatory motion. That means in first minute it is traveling 1 kilometer. In second minute also it is traveling same distance with the same interval of time. The second minute also it is 1 kilometer. Then we can say that the car is having a translatory motion. The car is having a translatory motion. Now, depending upon the nature of path, we have divided this one into 3. Rectilinear motion, curvilinear motion, and circular motion. These 3 will come under translatory motion. Translatory motion means what? The object is going to cover equal distances in equal interval of time. Then, what is rectilinear motion? I said that this object, if the object is covering same distance in same time, then we will call as a translatory motion. If the translatory motion in a straight line, I can say that it is a rectilinear motion, depending upon the nature of path. Path will be straight. The next one, for example, a car is moving in a straight road and a board is moving in a straight line. An apple is falling from a tree, it's also in a straight line. Mango is falling from the tree, it's also in a straight line. These are all are examples of rectilinear motion. The next one is curvilinear motion. What is curvilinear motion? If the path is curved, not just like this, no? This will be a curved path. It will be a curved path. Rectilinear is a straight path. This will be a curved. If the object is moving on a curved path, it is curvilinear motion. Will come under translatory motion. Then, what are the examples? A cyclist is racing on the curved track. Is an example. Earth is revolving around the sun or as curvilinear path. Is it? Then, what else? A car is taking on a turn, that means the road is not straight, there is a curve is there. So the curved part, if the car is taking a turn, it's also said to be rectilinear motion. Or it will come under curvilinear motion, will come under translatory motion. The next one is circular motion, that means it will be a circulatory motion. The point, there will be a fixed point at the middle, and from that axis it is just a revolving circulatory. That is also example. What are the examples of circulatory motion? The motion of a child sitting on a merry-go-round or a giant wheel and rolling around the hammer chain before going is an example of circulatory. That means in the park and you are having a round now, you will be just rounding. And this is fixed on an axis, so that you can say that it is a circulatory motion. This three will come under translatory motion. Then, second type of motion is rotatory motion. When an object rotates or spins about a fixed axis, it is said to be rotatory motion. For example, that spinning top. Spinning top. When you are spinning top, it will be fixed on a fixed axis and it will be rotating. That is called the rotatory motion. For example, fan. Our ceiling fan is fixed on an axis and the fan is rotating around that axis. Is an example of rotatory motion. Wheel of a moving car, car wheel. Car wheel is actually round in shape and axle is between two wheels. There will be one axle connected and these wheels are running around the axle. That is also an example of rotatory motion. And the next one is oscillatory motion. Third one is oscillatory motion. Oscillatory motion means what? When the object is moving to and from. For example, when you are swinging on a swing, it will be moving to and from like this. It will be moving to and from. Or pendulum of a clock, it will be moving to and from. So that type of motion is called oscillatory motion. Swinging motion and swinging pendulum of what example. In the oscillatory motion will come one more vibratory motion. The oscillatory motion, one more vibratory motion. What is vibratory motion? Vibration means what? For example, you may not see that tuning fork in this in page number 20, figure 2.11. The motion of arms of the tuning fork is a Y shape. It's just like a Y shape, and if you are hammering here, it will be just moving, vibrating. So this type of motion is front and back motion. That is called a vibratory motion. Will come under oscillatory motion. And one more thing is there, when we are in the assembly time earlier we were used to hammer. We will hit on a drum. When sound is produced, how the sound is, that means that side of that drum is going to be vibrated front and back. That is also example of vibratory motion. And the next one is repetitive motion. Repetitive motion. That means same kind of motion is going to be repeated. Same kind of. When an object moves such that it repeats its motion after a certain interval of time, it is said to be in respective motion. And repetitive motion. And this repetitive motion of two types periodic motion and non-periodic motion. Periodic motion and non-periodic motion. For example, the pendulum of a clock. Actually, I consider that it is an oscillatory motion. Yes, it is moving front and back, and we know that this movement will be same, repeated the same interval of time. If the motion is repeating the same interval of time, then that is called the periodic motion. That is called the periodic motion. What are the examples? The motion of the pendulum of a ball clock is an periodic in nature. Then, Earth always takes 365 days to complete one revolution around the sun, that is 1 year. And this one revolution is repeated every 365 days. Okay, these all are examples of periodic motion. The next one is non-periodic motion. What is non-periodic motion? The motion that repeats itself but not after a regular interval of time is called non-periodic motion. That means the motion will be repeated but not at a particular interval of time. If it is sometimes if it is repeated in 2 minutes, the next repeated motion sometimes will be 4 minutes or 5 minutes. Then again sometimes it will be 10 minutes or 4 minutes. So like that the time interval changes but the motion is repeating, then that is called a non-periodic motion. If the motion is repeats at the same interval of time, it's periodic motion. It's not in the same interval of time, it is non-periodic motion. Then next one is the random motion. What is random motion? That means the object is moving with not specific path. There is no specific path, or there is no specific velocity or frequency or no specific speed. It is depending upon that particular object. For example, the motion of a butterfly. The butterflies they will be sitting on a flower and they will be just going out to the flower, and as they like, sometimes they will be faster, sometimes they will be slower, sometimes they will go to this side, sometimes they are going to the other side, back, front, wherever they are, without any specific path or any specific speed. If the motion is happening, then that is called random motion. That is called random motion. Okay, now the last topic is combination or multiple motion. Combination or multiple motion. Already we have discussed about the 5 types of motions. In 5 types, again we have seen little more. Then combination of motion means when an object possesses 2 or more type of motion. When an object possesses 2 or more type of motion, then we can say that it's a combination of motion. It's a combination of motion. What are the examples? Some examples are given in the textbook. The earth rotates around its axis. That means the earth is rotating around above its axis. That is rotatory motion around an axis. Same time what happens? Earth is moving in a circular path or a curvilinear path. So that is a curvilinear motion, and this rotation around the sun is at the same time interval 365 days. So periodic motion. So more than 2 types of motions are there. 2 or more than 2. They are rotatory motion, curvilinear motion, will come translatory motion. Then the last one is periodic motion, repeating the same in the 3 types of motion. Then second one, when a bowler delivers a ball, actually when the players are playing again, he will deliver the ball. The ball will be moving towards the batsman. That is translatory motion. Then plus the ball will be revolving. That is a rotatory motion. So 2 types of motions are there: rotatory motion and translatory motion. Then third one is a drilling machine used for making a hole in wood has both rectilinear and rotatory motion. That means the drilling machine will go under the inside the wood or inside the wall. So it is moving front. That is a rectilinear motion. In a straight way it will go inside. The same time it is rotating also. 2 types of motions are there. Then the wheels of the bicycle rotate. When you are riding the bicycle, what happens? The wheels of the cycle rotate, rotatory motion, plus you will be moving towards front. That is translatory motion. And this translatory motion, if you are riding in a straight path, it is Again here, if you are learning that bicycle, it is curvilinear. Okay, these are the types of motion. So this much we are discussing today. And one activity is given on page number 22. You have to write whether it is translatory or circulatory types of motion. And go through the study questions, and related to this topic, you may write the answers on your copy. Thank you.